Okay, in this presentation, this is a continuation on the Maclaurin series stuff. The Maclaurin series for tan to the minus 1 of x is x minus x cubed over 3 plus x to the 5 over 5 minus x to the 7 over 7. Write down the general term for the series. Now this follows on to stuff like the ratio test, so it actually it informs me as to a couple of decisions I'm going to take as to how to go about doing this. Just first off, remark that the first term is, let's undo that. The first term is x, then minus x cubed over 3, and so on. Now, let's just suppose it was something different. 1 plus x squared over, or 1 plus x squared over 2, or something like that, and so on. The important difference here is that there's a constant term here at the start, whereas this one begins with x. Okay, so this is what we're dealing with. Okay, now as a result of that, I am going to use this indexing structure, and the indexing structure essentially n equals essentially 1, 2, 3, 4, and so on. So this is what we're going to call one indexing. Now, if it was something similar like this, zero indexing might come in useful. So you go 0, 1, 2, 3, and so on. Now, I'll sort of make references to this zero indexing approach, even though the one indexing starting with 1 will be actually the only one that's actually useful in the long run. But again, the key thing there is at the start we have an expression in x, where here we have a constant term, which is actually x to the 0 if you think about it, and also x to the 1 and x squared. Actually, that's a very good sort of thing to point out, actually. If you have a constant term, or something like a power of a constant, it is x. You can consider it as x to the 0, x to the 1, x squared, and so on. Okay, now, so that's the first part. Again, this explains the rationale why I went one indexing, but I'm going to talk about zero indexing as well. Now, so one indexing, first off, you notice that we have odd numbers up there, okay? Just as a remark, actually, it would help, actually, if you're finding this a bit hard to read on YouTube, to go into full screen mode. What we have there is odd numbers. So I'm going to write down here n, 1, 2, 3, 4, and it's just over here, 5. Now, the even numbers. We're going to write them as 2n, which is 2, 4, 6, 8, 10, and so on. What about the odd numbers? So 1, 3, 5, 7. How do we get them? Well, we simply go 2n minus 1. So that's as simple as that there. So 2n and 2n minus 1. Okay, it's as simple as that. Now, if, for argument's sake, you were dealing with zero indexing, you would go even numbers would be 2n. That counts 0 as an even number, so that would be 0, 2, 4, and so on. And odd numbers will be 2n plus 1, 1, 3, 5, and so on. Okay. Now, really, 0 isn't either odd or even, but it's just the way it's in the sequence. It just gets treated as a even number. Okay, so anyway, the important thing is 2n and 2n minus 1 for even and odd respectively. Now, next important thing to consider is that we have an alternation between positive and negative signs. So plus x minus x cubed over 3 plus x to the 5. So if you consider this, plus 1 minus 1 plus 1 minus 1, and so on. we can represent them as powers of minus 1. Okay, so minus 1 the power of n, what would that be? Well, that would be minus 1, 1, minus 1, 1, and so on. As to say, minus 1 to the power of 1, minus 1 squared, minus 1 cubed. I should really put them in brackets. Minus 1 to the power of 4. Okay, that's all well and good, but what we need is this. So what we're going to do is change it to minus 1 to the power of n plus 1. By the way, let's just be clear about something. We're one indexing here. So that will give us minus 1 to the power of 1 plus 1 is minus 1 squared. Next term will be minus 1 cubed, minus 1 to the power of 4, and so on. That gives us the answers we're looking for. Plus 1 there, and so on. So for 0 indexing, or sorry, 1 indexing, we would use that. If we were actually just a sort of remark, I'm not going to do it out, but if it was a case of 0 indexing, as in n equals 0, 1, 2, and so on, you'd actually minus 1 to the power of n would be fine, because the first term there is 0, so minus 1 to the power of 0 gives you 1. Okay, so that's just a sort of by the by remark. Okay. Now, we're going to put it all together now. We've talked about a lot of useful identities. Let's just put them all together. So x, so what we have first off is x to the power of odd numbers. So u of n equals 2n plus 1, sorry, 2n minus 1. Over x to the power of n 2n minus 1. Okay, and also we have to alternate between plus and minus, the plus and minuses. So we have minus 1 to the power of n plus 1. Okay, so that actually would give us a general term. Again, this part's very important. Actually, just specify what n is. 1, 2, 3, and so on. If you were to do it, and again, this is a bit of a dead end because, sorry, that's the correct answer. Now I'm going to talk about 0 indexing. The thing about 0 indexing is that it's a bit of a dead end because if you consider ratio tests and stuff like that, you want it as un and un plus 1, so you need u of n. So u of n, the first term there would be, this is n now, n, 1, 2, 3, 4, and so on. That's not what we have here. The first term is x to the power of something, 0. So in this case, what you do is n plus 1. So 0 will be, you can't have a 0th term basically, or a first term. So essentially, u of n plus 1 is the first term, and so that would be, if you get my drift, like actually, so u of n plus 1. Once you look at the mathematics of it now in a second, you'll sort of see what. So minus 1 to the power of n times x 2n plus 1 over 2n plus 1. Okay. Okay, but if you evaluate that for 0, you get u of 0 plus 1 equals minus 1 to the power of 0, x 2 to the power of 0 plus 1 over x 2n plus 1, 2 to the power of 0 plus 1. Sorry, 2 times 0 plus 1, and that will give you 1 times x to the power of 1 over 1, which give you the first term. Anyway, the point of that is, sorry, just to work back, is to get you're set if you're using zero indexing, you're setting the expression up in the context of u of n plus 1. Now, that's the important thing because that's not helpful for other things like the ratio test and so on. So that's why I just sort of mentioned it. It is handy to know in general how to sort of work with zero indexing, but starting with zero. But for the stuff like you will work with the Maclaurin series and stuff like that, it's best to go with one indexing because it makes life so much easier when you're sort of working on for other questions. So one indexing, there you go. I'm going to leave it there actually because that's talked enough about that. Okay. So actually, just to read over this and those useful identities I talked about for odd numbers and even numbers and alternating signs, those are really useful. Okay, we'll leave it there.